Hello girls, hello grade 9 IG. Today we are going to start with chapter 27, Reflection of Light. We talked before about reflection in chapter 25 in the properties of waves. Today we want to study reflection with more details. First of all, what's the meaning of reflection? Reflection occurs when light bounces off objects or surfaces. So now we know that everything around us that we can see, they reflect light. When you look at any object, now here, this pencil, how I can see this pencil? Because this pencil reflects the light from any source of light around or inside this room. So a light will reach this surface or the pencil, then it will reflect in so many directions. Some of these rays or reflected lights, they will enter my eye so I can see this pencil. So we have reflection everywhere, okay? We can use a mirror to change the direction in which the light is traveling, but some surfaces, they reflect light more than other surfaces. Okay, the same as what? A mirror. A mirror is made of what? A mirror is made of glass. It is a glass. One side of this glass is depositing a thin layer of silver nitrate on one side of a piece of glass. Okay, so this side of glass, it reflects light very well because this part of glass is smooth and shiny. Okay, so the mirror is smooth and shiny, that's why it reflects light very well, not the same as any other surface. Let's look at this example. I have a source of light, so I have light rays. They are coming into the mirror. What happens to these light rays? They reflect from the mirror. Okay, let's now look here at this figure. We have something we call it law of reflection. Law of reflection, it is the angle of incidence equals the angle of reflection. How? Let's study this figure. Here I have a mirror. Here I have incident ray, the ray that is coming from the source of light toward the mirror. We call it incident ray. We have another ray, we call it the reflected ray, the ray that is reflected from the mirror to our eyes. Okay, this is the reflected ray. Now, there is an angle, we call it angle of incidence. It is the angle that is between the incident ray and a line, we call it normal. What is this normal? This is an imaginary line. We don't have it. Now, when you look at a mirror, you don't see this line, but it is perpendicular to the reflected surface. So for the mirror, it is the line that is perpendicular to the mirror. In this case, where is the perpendicular line? Here it is. This is the normal, okay? What do we want this normal? To measure the angle of incidence and angle of reflection. So the angle of incidence, it is the angle between the incident ray and normal. Angle of reflection, it is the angle between the reflected ray and the normal. The law said that the angle of incidence equals the angle of reflection. Yes, and that's true, and it is a law. Okay, so if the angle of incidence here is 30 degrees, direct the angle of reflection is 30 degrees, and so on. Okay, good. Let's continue. We have some applications for reflection of light. We have something, we call it device, we call it a periscope. What is a periscope? Look at this. For sure you saw this device before in videos, in movies. Let's see how this device works. Look at this example. It is consists of what? Long tube. Here is a long tube that is connected to two short or small openings or tubes. Okay, what happens in this case? Let's see that here I have a tree outside and I am under the water. I want to see what's happening above the water. I can't see while I am down, so what I use a periscope. How I can see the tree that is outside, or a ship, for example, or a boat, or whatever. Now we know that light reach objects, so the light will reach this tree that is outside, so the tree will reflect the light in different directions. Some of these lights will enter this opening of the periscope, and we know that light travels in straight lines, and this is true even in this case. When the light reaches this point, what do we have here? I have a mirror, and what I have here down, I have also a mirror. So I have two mirrors that are parallel to each other. So what will happen in this case? When light enters from here, it will reflect it from this surface toward down, then from this mirror to the left to your eyes, so you can see the object. And the angle between the entering light and the reflected light here, 90 degrees. So what do you understand? Now we know that the normal is what? Perpendicular to the surface. So here it will be. So if the total angle is 90, so angle of incidence and angle of reflection 45. Okay, so we're still following the law of reflection. Is it clear? Good. The last thing now in our lesson is regular and diffuse reflection. We have two types of reflection. They depend on the type of surface. We said at the beginning of the lesson that mirrors, they reflect lights and we can see the images better than other objects. Now all objects, they reflect light, but some objects, they form a good or clear image. Other objects, no, we can see them. Okay, for example, a mirror, because the surface is very smooth and shiny, so all the incident rays, they will reflect regularly, and all the incident rays are parallel and the reflected rays are parallel, so you can see the image of the object clearly. We call this type of reflection regular reflection in plane mirrors. Diffuse reflection. Diffuse reflection, when you have a rough object, a rough surface, not smooth, not shiny, what will happen? Now the incident rays, all of them are parallel, they are coming to the surface, but when they reflect in different directions. Why? Look at the surface here. So the normal at any point here, it will be not the same. The normals will not be parallel here. The normal will be parallel. All the normals are here, parallel to each other. Here, the normal for this part of the surface, it will be here. The normal for this part of the surface will be here. That's why the rays will reflect in different directions, but at the end, they are still following the law of reflection, that the angle of incidence equals the angle of reflection. But not all rays, they don't touch the surface at the same angle, because the normal here is not the same for all parts of the surface of this surface. Okay, that's why we can't see an image in this case of reflection. We call this type of reflection diffuse reflection. Look here, these are examples for regular reflection and diffuse reflection. Look at the image here. The water, when it's still, is not moving, no waves in the water, so you can see the image clearly because all the rays will reflect the same direction. But in this case, let's say this water, it has waves, for example, so what happens here? You will not see the image clearly because the surface is not smooth, okay, and it has waves or whatever. Okay, that's all about our lesson. Here there is a link at the end of the PowerPoint. you can open it and find a game. It has questions about the lesson to make sure that you got everything and you understood everything in the lesson. Thank you.